We have one special type of trapezoid we're going to talk about here. It's an isosceles trapezoid. And just like isosceles triangles have two sides that are the same. Well, an isosceles trapezoid has two sides that are the same as well. It just happens to be that those sides have to be the legs, all right? And the reason for that is because if the bases were the same, if the parallel lines were the same, I would end up automatically having a parallelogram and no longer having a trapezoid, okay? And so an isosceles trapezoid is when the legs are the same, when the legs of the trapezoid are congruent, okay? And isosceles trapezoids have some special properties. The first special property they have is that for an isosceles trapezoid, the base angles are going to be congruent. And this is very similar, once again, to something we had with isosceles triangles. With isosceles triangles, the angles across from those sides were congruent because of the special relationship inside the triangle. And this is kind of the same way. And when you think about that, the reason for that is kind of because when we think about a trapezoid, it's like a piece of a triangle. Watch this. If I were to kind of extend these sides up, see how it gives me a whole triangle? That's actually an isosceles triangle now. The trapezoid's like the bottom piece of that. And so like if I looked at this guy and this guy as the congruent sides of the triangle, that means these two angles would be congruent, okay? And it works kind of the same way when we talk about an isosceles trapezoid, okay? It's those two angles that are the same. And really an easy way to identify which two base angles are the same, like when you talk about a base angle is an angle that's touching a base. Well, that's all of the angles, okay? When we talk about base angles that are congruent, we're talking about the base angles that are touching the same base, okay? And so when we look at this guy, this angle right here, the one that's labeled, the 77 degrees, is touching this bottom base. And the other angle that's touching that bottom base is angle D. So those are the base angles that are congruent, okay? So when you look at these, this is also 72 degrees, right? Or 77 degrees right here, okay? The other thing that's special here, and it's not labeled anywhere, we didn't say that this was special, but because of the fact that these are parallel lines, let me extend this guy a little bit. So once again, if I extend that side, we know the parallel lines go off the same angle. So we know if this guy right here is 77 degrees, that this guy right here is also 77 degrees. Okay, remember the parallel lines have to go off the same angle. And the thing that's interesting here now is these guys right here form a line. So when we look at these two angles, the 77 and this guy in here, they have to add up to 180 degrees, which means that this guy has to be 103 degrees. Okay? And if you remember when we talked about parallel lines, we did have some special properties where we could take some shortcuts. We talked about it very briefly. But right here, the two angles inside, in between the parallel lines together, they're always going to be supplementary. Okay? And that's important from the perspective of this because we wanted to find angle B. Well, now I have another set of base angles. Look at this base that I have. If I look at this base, there are two angles that are touching this base. This angle is touching that base, and angle C is touching that base. So B and C are still base angles because they're still touching a base. And they're congruent base angles because they're touching the same base, okay? And so because these are touching the same base in an isosceles trapezoid, they're going to be the same. So this is 103 degrees also, okay?